Okay, let's dive right into this explainer and absolutely crack the code behind Cambridge Computer Science and IT exams. Picture this. You're sitting in the exam hall. The clock is ticking loudly. You flip open the paper, and you're suddenly staring at a massive, complex system scenario. Your heart rate spikes. You're feeling completely overwhelmed by the sheer amount of data on the page. Listen, if you've ever felt that exact panic, you are absolutely not alone. Today, we are focusing on one of the most notoriously misunderstood areas across the entire Cambridge syllabus. Whether you're taking 0417, 0478, 2210, 9618, or IT 9626, we're talking about control technologies, sensors, and their precise real-world uses. Here is the absolute truth that is going to change how you study forever. There is no paper. There are only patterns. What looks like a terrifying, unpredictable exam is actually a highly structured matrix. And today, we're going to learn to see the exact code behind every single question those principal examiners throw at you. We are moving away from blind guesswork, and we're stepping into absolute, unshakable mastery.
Now, what's really interesting about this slide is how it challenges a massive illusion. It's incredibly easy to fall into the trap of thinking that simply memorizing facts is enough to conquer this module. So many hardworking candidates fall into what I call the rote learning matrix. Think about it. They spend hours, days, literally weeks highlighting their textbooks, memorizing the exact dictionary definition of a temperature sensor, a pressure sensor, or an analog-to-digital converter. But then, exam day arrives. They open the booklet, and the question absolutely does not ask for a basic definition. Instead, it hits them with something like, evaluate the implementation of a closed-loop feedback system in an automated greenhouse environment. Boom! Suddenly, all those perfectly memorized facts are totally useless if you don't actually know how to apply them to that greenhouse context. The matrix wants you to think rote memorization equals exam success. It's a lie. Today, we break you out of that matrix for good.
We see this exact tragedy play out constantly in the examiner reports. Let's look at these two student archetypes on screen, because I guarantee you know someone like this, or maybe you've even been one of them. First up, we have Alex. Alex is the over-preparer. Alex overloads the page with raw computer science and IT facts, but completely lacks any critical analysis. If the exam question asks about an automated traffic light system, Alex will confidently write half a page defining what a microprocessor is, how it's manufactured, and its clock speed, without ever once mentioning the cars, the sensors in the road, or the actual traffic flow. It's a huge data dump with zero relevance. Then on the other side, we have Sam. Sam is watching the clock. Sam rushes, provides incredibly vague answers, and completely misses the specific context of the command words. Sam might just scribble down, sensors send data to the computer, which changes the lights. Listen to me carefully. Neither of these approaches will secure the marks. They are both getting destroyed by the examiner's red pen because they completely miss the command word requirements. We have to fix this. Here is your Control Technology Success Blueprint, downloading the exact procedural frameworks demanded by Cambridge principal examiners. We are going to hit 5 critical checkpoints today: the core principles, the method mark strategy, dodging examiner warnings, critical analysis mastery, and finally, exam strategy application. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into the actual architecture of a perfect answer.
Section 1. Core Principles. Let's explore the theoretical architecture of a top-tier exam response. The assessment framework explicitly prioritizes analytical depth over superficial breadth. It is absolutely crucial to understand that the architecture of this module rests heavily on precise definitions, causal relationships, and integration. Examiners are not impressed that you know 100 random things superficially. They want to see that you know how 3 core concepts interact on a deep, systemic level. Examiners are practically begging candidates on every page to show a logical, structured reasoning process. As you'll see, top-performing students exhibit a connected, conceptual understanding that is completely transferable to totally unfamiliar contexts. You might have studied a temperature sensor in the context of a smart home's central heating system, right? But can you apply that exact same underlying logic to a chemical reactor cooling system in a factory? That is what the exam actually tests. To achieve this, top students use structured answering frameworks, specifically the PEAL framework. That stands for point, evidence, explanation, link. You make a clear point about the control technology. You provide evidence extracted straight from the specific scenario given. You give a technical explanation of the causal link. And finally, you link it all back to the overall system requirement. I want you to mentally take 30 seconds right now and think about the last answer you wrote. Did it have a point, evidence, explanation, and a link? If not, you're leaving marks on the table.
There are exactly 3 cognitive domains targeted in these exams: knowledge and understanding, application, and analytical depth. So the crucial takeaway here is that examiners aren't just looking for isolated definitions, they want to see the whole living, breathing system. Knowledge is simply knowing what an infrared sensor is. Application is taking that knowledge and explaining exactly how it detects a barcode on a fast-moving conveyor belt. Analytical depth, the highest level, is evaluating why that specific infrared sensor might actually fail in a highly dusty factory environment, and then expertly recommending a better alternative. Think back to Alex and Sam. We are going to transform those red pen marks into green check marks right now. If Alex forces themselves to move from just knowledge into analytical depth using the PEL framework, their mark potential skyrockets from 20% straight to 100%. If you are only hitting domain 1, you are literally capping your grade before you even finish writing the sentence.
Section 2. The Method Mark Strategy. Let's look at how systematic processing is going to save you.
This brilliantly illustrates why we need to move to the method mark strategy. In control technologies, getting the final answer quote-unquote right is often way less important than proving to the examiner exactly how you arrive there. Cambridge candidates must demonstrate mastery of fundamental principles through systematic processing. The examiner is actively tracking your logic, and marks are awarded for the actual process. Let's see how this builds into a standardized 5-step sequence. Step 1, deconstruct the prompt. You literally circle the command word. Is it describe, explain, or evaluate? Because each of those demands a completely different approach. Step 2, extract relevant data from the scenario text. Step 3, apply the correct analytical framework, like PEL. Step 4, execute your analysis using clear, precise technical notation, no slang. And Step 5, verify your results and present them using proper headings and formatting. If you follow this exact procedural algorithm, you are practically forcing the examiner to hand over those top marks.
Data interpretation is absolutely critical. You must systematically extract from tables, interpret relationships, and only then draw evidence-based conclusions. Let's do a quick interactive workshop right here. Challenge 1. Data scan. Imagine a complex data table just popped up on your exam paper showing sensor polling rates on the left and system latency on the right. I'm putting a 60-second visual timer on this challenge in my head. In those 60 seconds, you must extract the core trend. You scan the numbers, you map the causal link, meaning you notice that as the polling frequency increases, the microprocessor load goes up, and then you draw a rock-solid conclusion. You don't just say the numbers go up. You say, an increase in sensor polling frequency directly correlates with a spike in microprocessor latency, suggesting a bottleneck. That is how you process data like a top-tier candidate.
Moving on to Section 3, Dodging Examiner Warnings, where we uncover the top mistakes straight from the principal examiner reports.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's dive into the most vital intelligence you can get: the top warnings directly from principal examiner reports. Years of these reports reveal shocking patterns. It's the exact same mistakes, year after year, losing candidates' marks. Let's do Challenge 2 of our interactive workshop, Find the Flaw. I'm going to give you a flawed sample paragraph, and I want you to spot why it fails. Here it is. The sensor measures heat and tells the computer to turn on the fan. So, what's the flaw? Actually, what isn't the flaw? It is way too vague. The examiner demands specific details. The temperature sensor captures analog data regarding ambient temperature and transmits it to the microprocessor. Second trap, format and presentation. Students write giant, unreadable blocks of text. Use bullet points if the command word allows it. And the third, absolutely deadliest trap, ignoring the context. If the exam scenario is about an automated nuclear reactor and you write a generic X-book answer about a smart home thermostat, you will score a 0. Context is king.
Now, what's really interesting about this slide is the definitive examiner alert regarding key terminology. Candidates consistently confuse terminology, so you must define terms before using them. The reports show that students constantly mix up terms like sensor, actuator, microprocessor, and closed-loop feedback. Listen, a sensor reads the environment. An actuator creates the physical movement or change like a motor or a valve. If you swap those two words in your exam, the examiner instantly assumes you do not understand the fundamental theory of computer science. Always define your key terms accurately right at the start of your extended responses to lock in those foundational marks before you build your complex arguments.
Section 4. Critical Analysis Mastery. Let's talk about leveling up your responses to hit those highest grade boundaries. The crucial point here is moving beyond basic knowledge to critical analysis, mastering the higher-order assessment objectives. Anyone can describe a system. A descriptive level answer just lists features, like a light sensor detects ambient light levels. That's nice, but it's basic. This side-by-side perfectly demonstrates the massive leap from a descriptive answer to a high-scoring evaluative response. An evaluative level answer identifies limitations, questions assumptions, and offers alternative interpretations. It sounds like this. While the light sensor effectively detects ambient levels, a critical limitation in this outdoor street lighting scenario is its susceptibility to false triggers from passing car headlights, assuming the sensor is positioned too low on the pole. Do you see the difference there? Let's do challenge 3, speed writing. If I gave you 30 seconds on the clock right now to write one perfect Peel paragraph evaluating a moisture sensor in a desert environment, could you do it? You'd need to state the point, provide the evidence of the extreme heat, explain the potential hardware failure, and link it to system reliability. That's critical analysis mastery.
When comparing alternative approaches, it's not enough to just list facts. You must use comparative connectives and draw justified conclusions. If you get an 8-mark question asking you to compare 2 different sensor setups, you need to memorize this 4-step checklist. First, identify similarities and differences. Do not just write 2 totally separate paragraphs about the 2 setups, you have to put them head to head. Second, actively use comparative connectives. Words like whereas, conversely, similarly, or on the other hand, are literal signals to the examiner that you are analyzing, not just describing. Third, support each comparison with hard evidence from the scenario text. And finally, draw a firm conclusion about their relative importance. Which system is actually better for this specific scenario, and why? Without that final justified recommendation, your comparative analysis is completely unfinished.
Finally, Section 5, Exam Strategy Application. It's time to connect the syllabus and put it all together. Let's pull this all together into a practical exam strategy. We have a complete cheat sheet recap right here, and your mark potential progress bar is reaching 100%. To guarantee top marks, you must apply 3 unbreakable rules. Number 1, command word decoding. Number 2, Peel framework application. And number 3, the time management matrix. But this slide brilliantly illustrates the ultimate cheat code, breaking out of the 3.2 module silo and showing examiners you understand the entire IT network. The theoretical architecture of control technologies doesn't just exist in a vacuum. A sensor array integrates with networks, databases, and cybersecurity. If you are evaluating a smart city traffic system, mention how the sensor data is transmitted over a wide area network, or how the resulting central database needs to be secured against unauthorized access. Referencing these cross-topic connections proves to the examiner that you don't just know a chapter in a textbook, you have a holistic conceptual understanding of computer science.
Now that you've seen the systematic patterns behind the exam matrix, how will you systematically deconstruct your next past paper? You have the tools, you know the code. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.